Consider the function f of x is equal to 2x cube minus 3x square in the domain -1 to 2. The global minimum of this function f of x is. Let's understand what global minimum is. A global minimum is a point where the function value is smaller than all other feasible points. So let's write here. Let's understand this problem using graphical method. Okay. The given function in this problem is f of x is equal to 2x cube minus 3x square, and the function is defined as f of x such that its domain is -1 to 2, and let's say the codomain is r. R stands for real number. First, let's find the value of this function at the endpoints of the domain. So f is right here. F of -1 will be equal to -5, and f of 2 is 4. Now, to know whether the function is increasing or decreasing, let's find the first derivative of this function. So f dash of x will be equal to 6x square minus 6x. So if we equate this to 0, we get x is equal to 0 and x is equal to 1. Now let's find the value of function at x is equal to 0 and 1. So f of 0 is 0 and f of 1 will be -1. So now let's try to plot the graph. So in this xy plane, we know that at f is equal to 0, the value of function is 0. So it is at the origin. Now at x is equal to 1, the value of function is -1. So let's mark it somewhere here. So this is 1, -1. And at the endpoints of domain, that is at x is equal to -1, the value of function is -5. So let's say -1 is here and -5 somewhere here. -1, -5. And at x is equal to 2, the value of function is 4. So somewhere here, 2, 4. Now we also know that its slope is 0 at x is equal to 0 and x is equal to 1. That means at this point and this point, 1 minus 1 -1, the slope of the function is 0. Now to understand the curvature, we must find the second derivative of the function. So second derivative of the function will be 12x minus 6. Now if we equate this is equal to 0, we get x is equal to 1 by 2. That means at x is equal to 1 by 2 here, till this point, second derivative, let's write like this, second derivative of x in the domain -1 to 1 by 2, it is lesser than 0. Therefore, we can say from here, the graph of f of x will be concave down. Okay, so from -1 to 1 by 2, it will be concave down, and f double dash of x in the domain 1 by 2 to 2, it is greater than 0. That means concave up. Okay, now let's plot the graph here. From -1 to 1 by 2, it is concave down. So let's draw like this. And the slope is also 0 at 0. At the origin, the slope is also 0. And at 1, x is equal to 1, the slope is again 0. Now from 1 by 2 to 2, it is concave up. So let's draw like this, the concave up. Okay, so the curve will be something like this. So at these 2 points, we see that f dash of x is 0 here, and at the origin, f dash of x is equal to 0. And from -1 to 1 by 2, f double dash of x is lesser than 0, and from 1 by 2, from this point beyond, from 1 by 2 to 2, f double dash of this function is greater than 0. So this is how the function 2x cube minus 3x square will look like. Okay. Now we can see here that at point this, let's say this point be A, this be B, this origin let's say O, and this point be C. So we can see that at A, let's write here, at A we have the global minimum, that is the minimum value of this function defined in the interval -1 to 2. So this point, let's write here, it is 2. So at A we have global minimum whose value is, the value of the function is f minus 1 is equal to -5, and we have a local minimum at B and global maximum at point C and local maximum at the origin. Okay, and this function, let's write the name of this function is, this curve is y is equal to f of x. Now let's go back to the problem. So the global minimum of f of x is -5. For detailed information, you can refer to the NPTEL course, lecture number 17, Maxima and Minima of Functions of Two Variables on Engineering Mathematics by Professor Jitendra Kumar of the Department of Mathematics at IIT Kharagpur.